first. Recording, then only I share. Okay, one more time. Share. Okay, right. How many already? How many now? Participants, 7. Participants, 7. Okay, 7, 7 lah. We start already. Don't want to wait already. Same those coming in. 7. 3 or 4 this morning one. Now coming in again. Okay, we start. Okay, today we are going to learn about turning points. Another name for turning points, they are called stationary points. Okay, what are stationary points? Okay, let me list out all the stationary points. You look at this graph A, the stationary point is the minimum point here. Okay, if you look at graph B, the stationary point or turning point is the maximum point. Okay, if you look at the graph C, this type of graph, have you learned in your mathematics y equals to x cubed? Yes or no? Not yet. One Zarina taught you already. Y equals to x cubed. Now, this point at the center here is neither a maximum nor a minimum point. It is called the point of inflection that I show you. Okay, so the point of inflection, inflection. Another spelling is inflexion. So this is the point of inflection. Okay, so we are not going to study this point of inflection. We are going to look at these two types, minimum point and maximum point. Okay, so these are called turning points or stationary points. Now, if you look at the graph A, look at graph A, and you see I drag the point A, and after the minimum point, they turn up again. So can you see why this minimum point is called the turning point or not? See, it is after this point that the gradient turn in another direction. So that's why they are called turning points. Okay, then we look at the graph B. Look at graph B. Again, you see after this point, they turn in another direction. So it's called the turning point. Okay, at the maximum point, they start to turn. So they are called turning points. If you look at graph C, right, they go flat. Uh, they are hoping for the COVID-19 to the graph to become flat like this. Then after flat, then they go up again. So this is the turning point. So in our COVID-19, they're also waiting for this flattening of the graph. It's called turning point. Okay. So altogether, we have 3 types of turning point, but we are going to learn only these 2 types, A and B, maximum and minimum point. Okay. Now, what is the characteristic of this turning point? The characteristic is dy dx equals to 0. Okay, one more time, let me show you. Now look at the point A. As I drag this point A from left to right, okay, it's always from left to right. From left, go towards the right. So left to right means what? Left to right means uh, the value of x increases. So as the value of x increases, we are going to analyze what is happening to the gradient of tangent here. Okay, we're going to look at what is going to happen to the gradient of tangent. Right. So the gradient of tangent I have calculated and display here. Can you see this MA or not? MA means the gradient of tangent at the point A. What is the value now? Can you tell me what's the value, Ganga? Negative 2.1. Now, as I drag this point A towards the right hand side, the value of the gradient decreases. It becomes less and less negative. So I drag it further, it becomes negative 0.8. From negative 1 point something, it has reduced to negative 0.8. Now at one point, if you continue to drag the point, at one point, The gradient will be 0. The gradient will be 0. Exactly now. Can you see the gradient 0 here? Yes or no?
Yes, sir.
So you see the gradient is now 0. So this is our uh, turning point. This is our switching point. Now, after this, the gradient become positive, positive 0.91. If I continue to drag, it will become more and more positive. So if I ask you, what happens to the gradient when the point A moves from left to right? Can you tell me what happened? By looking at this, can you tell me what happened to the gradient at the point A? Anyone? But from your observation, what is happening to the gradient? Ah, anyone with a voice one?
Becomes positive.
Ah,
Yes.
actually it becomes positive, but the pattern, the trend is the gradient increases. From negative to positive, it means that it has increased. Okay, it has increased. So now we look at another graph. We're going to look at this maximum graph. Maximum graph, we look at the point B. The gradient of the tangent at the point B is displayed here. I've calculated it already. That's why last year I tried to give you this application. I don't know how many of you got it from me, right? It's very useful. You can do a lot of things using it. Now, so the gradient is displayed here. Now, one more time, we look at the gradient carefully, and I'm going to move the point B from left to right, meaning I'm trying to increase the value of x. So what happened to the gradient of B as x increases, or as B moves from left to right? What happened? Anyone? Bella Cookie, come. Bella Cookie is Shamimi, I think. Use your own name lah, Shamimi. What happened to the gradient? Tak boleh jawab. Anyone? Oh, this Liu Ying, no, not muting. So what happened? Liu Ying, what happened to the gradient as I drag the point B from left to right? What happened to the gradient? Can you see? Still no one answer. Someone answer lah. Yang Wan Li, can answer or
Become
not?
negative.
It becomes less and less.
Become negative. Negative.
Okay, at one point it will become 0. That is the turning point, it will become 0. Okay, at one point it will become 0. Where is it? My hand very shaky. Never mind. At one point it will become 0. After 0 it will become negative. After become negative, it will become more and more negative. So in general, what is the pattern that we can see regarding the gradient of this tangent? What is the pattern there?
It
Anyone?
becomes negative.
It becomes negative. From positive it becomes 0. From 0 it becomes negative. Increasing or decreasing? The gradient.
Decreasing.
Decreasing, correct.
Decreasing.
Yes. So,
Decreasing.
yes, correct. Now, as x increases, because I drag it from left to right, that means as x increases, because you go more and more right, that means the x become bigger and bigger. So as the value of x increases, the gradient actually decreases. Okay or not? The gradient decreases. So this is what we can see from the graph. Okay, right. Let me any questions so far? Any question? No. Yes.
No.
No. So we look at the graph C and the point C. What happened to the gradient? It decreases, right? As I move from left to right, it decreases until 0. At one point, it becomes 0. Okay? One more. One more. 0. No. Okay, no 0 yet. 0. Okay, becomes 0, right? So after 0, it will increase again. Now this type is the point of inflection. We are not going to study this type, right? Okay, now let me summarize what we have seen from this graph A, from the graph A, right? Okay. Okay. Can you see what I've written there? Minimum point. The first graph A shows the minimum point. No. What is the characteristic of this graph which has the minimum point? Okay. The characteristic is as A moves from left to right, the value of x increases. This is what we want, the x increases. The gradient of tangent changes from negative to 0, then to positive. Okay, this is in words. Symbolically, in symbol, we write down dy dx changes from negative to 0, from 0 to positive. So far, okay or not? So far,
Yes, sir.
yes. Okay. Now, the next thing is, since the gradient increases, the rate of change of gradient is positive. Now, we are talking about gradient. That means we are talking about dy dx. dy dx increases. Rate of change of gradient. Can you say the rate of change of gradient as dy dx? No.
No.
The gradient is dy dx. The rate of change of gradient is d2y dx squared. That is the second derivative, right? The first derivative is the gradient, is the dy dx. The second derivative, d2y dx squared, is not the gradient. It is the rate of change of gradient. Is that okay?
Yes, sir.
Okay. Now, if the rate of change of gradient, right? If the gradient is increasing, the rate of change of gradient is positive. Okay or not? We are talking about d2y dx square now. So there are two ways of looking at it. One way is looking at the dy dx by analyzing the gradient. Gradient changes from negative to positive. Another way of looking at it is looking at the second derivative, that is d2y dx square. Now this d2y dx square is positive. It means that the dy dx is increasing. So far, any question?
No.
No. Other girls, Ng Wei Ling, can hear me or not? Put up your thumb, Ng Wei Ling. Okay, very good. Thank you. Megan, can follow or not? Put up your thumb if you can
Yes.
follow. Yes, okay, very good. So this is about the minimum point. Now we are going to look at the maximum point. It is another type of stationary point or turning point. So how are we going to look at it? We again look at it this way. Now as the point B moves from left to right, the value of x increases. So there are two ways of saying it. B move from left to right. Okay, move from left to right. So the meaning of moving from left to right means the value of x increases. This is our x-axis. This is our x-axis, this one. Now this is our x-axis. Now if you move from left to right, that means the value of x is increasing. Okay, that is you can actually see from the graph. Okay, now the second thing I want to tell you is that the gradient of tangent. What happens to the gradient of tangent? Okay, at first, what value is it? Positive. Then after going through the turning point, what value is it? Negative. So
Negative.
yes, correct. So the gradient of tangent changes from positive to negative. This is in words. In symbol form, how are you going to put it? Because mathematics, we change it to symbol form, right? So in symbol form, we say dy over dx changes from positive to 0, from 0 to negative. In practice, you can just skip the 0 because turning point dy dx is always 0. So you can skip the 0 and you say it changes from positive to negative. If it changes from positive to negative, what type of turning point is it? Huh? Iman, what type of turning point is it? Change from positive to negative. Yeah? Sorry. Okay. What type is it, Iman? From positive change to negative is the maximum type, right? Next one. Now the gradient decreases. Decreases. The rate of change of gradient is negative. If the gradient decreases, the rate of change of gradient. Okay, we are talking about the rate now. We are not talking about the gradient. We are talking about the rate of change of gradient. So if the gradient decreases, the rate of change of gradient is actually negative. And how, in symbol form, what is the rate of change of gradient? It is d2y over dx squared. So d2y over dx squared is negative. Okay. So far, okay or not okay? Who else I can see? Where is this girl? Yeah, Ayn said okay. Where is the Liu Ying? Because she wrote a lot of d2y dx squared in her answer. So Liu Ying, now you understand what is d2y dx squared or not? Where's Liu Ying? Offline already. Where's Liu Ying? Huh? Or no, Liu Ying not here already, offline. So we go and ask Yang Wan Li. You wrote a lot of d2y dx squared there. So now you understand what is d2y dx squared or not? Liu Ying is back. Liu Ying, you wrote a lot of d2y dx squared greater than 0, less than 0. Now do you understand what is d2y dx squared or not? Hello? Show me your thumb if you understand what is d2y dx squared. Rate of change of dy dx. Okay, right. So that's all, right? That's all I want to tell. If you have anything, any question, you ask now. If not, then I'll go on to the next slide. Any question? Any question? Wei Ling, can hear me or not? Oh, yesterday you keep telling me cannot hear, cannot hear. So now I ask you, can hear or not? No answer, Wei Ling. Okay, right. So now, if you have no answer, I assume that you know what I'm talking about. We go on to the next slide. Okay. The summary. Turning points can be maximum, minimum, or point of inflection. Okay, this one very easy. Then at turning point, dy dx equals to 0. This is the summary of what I've shown you just now. At turning point, dy dx is 0. Another one, to determine the type of turning point, we have two methods. The first method is analysis of gradient. Second method is to find the second derivative. Okay. So far, okay or not? Kau Li Ting, okay or not? Show me your thumb, Kau Li Ting. Farish said okay, understand, very good. Farish, how are you now? Okay or not, your MS? Still doing well or not, Farish? I didn't see you so long already, don't know you can do or not MS. Farish. Okay, right. So can Farish can, then I don't care already. The rest don't want to answer me. Okay, right. This is what we have learned. Then how to put it in mathematics, how to calculate. So in order to do our calculation, I have listed out the steps here. Okay, number one, to find the turning point, you have to put dy dx equals to 0. This is for you to find the turning point. Then to determine the type of turning point, you have to use two methods. Method 1, analysis of gradient. You see whether the gradient change from negative to positive, then it's minimum. If the gradient change from positive to negative, then it's a maximum point. Another method is to find the second derivative. If d2y dx squared is positive, then the point is minimum. If d2y dx squared is negative, then the point is maximum. I go and close the door first. Okay, so far I give you some time to think over this. First step, find dy dx, put dy dx equals to 0 to find the turning point. That's the first step. Okay, second step, to determine the type of turning point, you can use method 1 or method 2. Method 1, find the gradient. whether it changed from negative to positive or from positive to negative. This method is very long, so we don't want. Normally we use this method. Find the second derivative, that is find d2y dx square. Okay, can? Megan? Okay, Megan. Ah, okay, right, thank you. Who else? Iman Farish. Okay, okay. Ng Wei Ling, okay, very good lah, Ng Wei Ling. Okay, you give some response, at least I know, or you are listening and people understand. Otherwise, I'm talking to myself. I don't know whether you know or not, right? Okay, next one. Example, right? Okay, so this is the assignment 1 that I've given you. The first question is y equals to this, right? So type out. Answer is here, right? So when I give you the video, you just go through the answer, see whether your answer is correct or not. Y equals to 3x squared plus 6x minus 2. This is the question. So what you want to do with this? You want to find the turning point and you want to decide whether it is maximum or minimum. Right? Next one. So the first step is to find the dy dx. This is our dy dx.
dy dx.
Yeah. Next step, you put the dy dx equal to 0. Why put dy dx equal to 0? Because we want to find the turning
We want
point.
to find the coordinates.
Yes, correct. We want to find the coordinates. So put dy dx equal to 0. I found out the x coordinate only because dy dx is in terms of x. So I found the x coordinate. I need to use the x coordinate and substitute into the y. When you use the x coordinate substitute into the y, then you're actually finding the y coordinate. So after finding the two numbers, this becomes a point, and this point is the turning point. So again, find dy dx, find the x, then find the y, and you have found the turning point. Okay. But how to determine the type of turning point? Okay, right. So the type of turning point, you use dy dx equals to 0 when x equals to 1. Now, in order to find and use the analysis of gradient, you have to take a point on the left. Left of what? Left of this x equals to -1. That means on the left is a number smaller than -1. So number smaller than -1, I choose -1.1. So just now, Farish asked me, can I take -2? Can I take -1.2? Can. As long as the number is on the left of the turning point. As long as the number is smaller than your turning point, then you can take that number. But don't take too far away. Take quite near to it, about difference of 0.1. The reason is if you take very far away, then there might be other turning points in between. Okay, so you just take a difference of 0.1 or 0.01 and take that point. So now I take -1.1 and I substitute into dy dx. I found out that the dy dx is a negative number. It means that the gradient is negative. So far okay or not? Kishania. Just come in only, Kishania. Can follow or not, Kishania? Never mind. Just came in, don't know anything. Okay, never mind. Calling you can teach her later, or you ask Karen. Karen always follow the lesson. Okay, right. So next one, I'm going to take another point on the right hand side. So the point on the right hand side, this point, the turning point is -1. On the right hand side of -1 is -0.9. Okay, now. So -0.9, I substitute into the gradient. I substitute the gradient, I get a positive number, which means that the gradient is positive. If you don't know what I'm talking about, let me show you the graph. Okay, the graph is like this. This is the center one. The center is our turning point. On the left of the turning point, I have -1.1. Can you take other numbers? Sure, you can take other numbers, right? But don't take too far away, something near to the turning point. On my right, I take -0.9. And you don't take a number very far away, just take a number quite close to -1. So I have chosen -0.9. Okay, for all these points, I want to determine the gradient. Can you see the gradient there? Negative 1.1, the gradient is a negative number. That negative number is negative 0.6. At the turning point, of course, the gradient is 0, right? And the point on the left, okay, on the left, sorry, on the right, negative 0.9, the gradient is positive. It's positive 0.6. So it's a positive number. So can you see the curve turn this way, go down, then flat, then go up again? So curving this way will give you a minimum point. Give you a minimum point. So far, can understand. Ayn was here just now. Sure can understand.
Yes, sir.
Ayn sure can understand. Maybe Ganga or who else? Megan or this Corey Ting or Zhang Hui Mei. Zhang Hui Mei was here just now, right? Shamimi was here. No, Shamimi not here. I think. Only Farish here. So now, after finding the gradient, you found out that the gradient is negative, 0, and positive. So what is your conclusion? Your conclusion is, since the gradient changes from negative to positive, it must be a minimum point. Why? Now, look at here. Look at how these lines are constructed. So when you construct this line, you see, yeah, CD is still negative. Okay, so we're going to look at the second method. Second method. Are you ready for the second method? Megan? Megan not?
Yes, sir.
Yes, sir.
Can, Megan can, ready? Okay, ready. So I carry on. Second method. Okay. Second method, I use another equation already. I use this example. No longer example A. I use the first example. Okay. The first thing, find the turning point. How to find turning point? dy dx equals to 0. Find dy dx. Put dy dx equal to 0. And after that, you have found the value of x. dy dx equals to 0. Find the value of x. So after finding the value of x, find the value of y. Reason? To find the coordinates of the turning point. So this is the coordinates of the turning point, the x and the y. Okay, so far okay or not? I go on to see. Kishania and Corey Ting, can or not?
Yes, sir.
Ng Wei Ling said okay or okay lah. The other two girls I don't know. Yap Wei Sin was here just now. Never mind. Atira Ayn also here just now. Okay, right. So after, hey, I wonder where is this Vikasini? You tell me cannot log in again. Never mind about Vikasini. Ask her to look at the video. Okay, so now I find d2y dx squared. This one very easy. From the dy dx, you find d2y dx squared. And d2y dx squared is a positive number. It's a positive number. So, what can you say? d2y dx squared is positive. Here, d2y dx squared positive, the point is minimum. So, the conclusion is minimum point. Okay, right. Now, we're going to look at one very difficult example. We're going to look at one difficult example, and it will really illustrate to you the usefulness of calculus in finding the turning point. Look at this equation, very complicated. Who don't know how to do this one?
Me, sir.
Angga, no.
I skipped the question.
You did the question, very good. Okay, I've marked already the one girl, two girls. Liu Ying and what's the other girl name? Yang Wan Li. They can do, right? So first method, you find dy dx. Okay, this is our dy dx. I'm not going through how to differentiate, right? I assume that you know how to differentiate. Then after differentiating, you put dy dx equal to 0. And you end up x to the power of 5 is 32. Now this is an odd number, Yang Wan Li. So when you take the fifth root, it is positive 2, no negative 2. Unless this is an even number, the index is an even number, then you have positive and negative 2. Okay or not, Yang Wan Li? Don't say I cut 5 marks from you, give you 95, then give Liu Ying 100 marks, then you get angry with me. This one you did wrong, right? So x to the power 5 is 32, x equal to 2, no positive negative, okay? So after finding the value of x, what must you do? Find the value of y. After finding the value of y, you get the turning point. So the first method, take 1 point on the left. You see this one is 2, or the point on the left is 1.9. Just take a difference of 0.1. It is not, it is just arbitrary. It can be any point as long as it is on the left. It's just an arbitrary point. Arbitrary point. So you substitute inside, you found out that the gradient is negative. Then next, you have to take a point on the left hand side. Okay, a point on the right hand side now. Okay, so take a point on the right hand side. The point is 2. So right hand side 2.1. So 2.1, you find the dy dx, find the gradient. The gradient is a positive number. So what can you say? Right? These are the 3 points. 1.9 negative. X equal to 2, 0. 2.1 positive. So the shape of the graph is like this. Negative to positive. So what type of point is it? Minimum point. Right? Minimum point. Okay, right. Now we're going to use the second method. Second method, same thing. The starting is always the same, right? Find dy dx. Put dy dx equal to 0 to find the x coordinate. To find the x coordinate. Then find the y coordinate. Right? Find the y coordinate. So after finding the y coordinate, okay, after finding the y coordinate, you have to determine whether this point that you have found is a maximum or minimum point. And we are not going to use the analysis of gradient. We are going to use d2y over dx squared. So d2y dx squared, unfortunately, is a function of x. It involves x. This is d2y. Earlier on, our d2y dx squared is what? It's just a number. There's no x there. Can you see the difference or not? So our d2y dx squared is a fixed number. Whereas in this case, our d2y dx squared is a function of x. So how to determine whether it's positive or negative? Is it a function of x? No problem. You just take our turning point 2 and substitute into this d2y dx squared. After substituting, oh, you found out d2y dx squared is a positive number. So positive number, what can you say? Positive number is minimum point. Positive number is a minimum point. So you have to explain it's a minimum point. So I've shown you both methods, and the video I will upload into YouTube, and I post it at the wall. I post it at the wall of all the classes, and you tell me the next assignment you try to do. Assignment 2 you can skip. You go on to assignment 3, and you tell me which questions you cannot do. Next lesson I will show you more difficult examples. You see, some of the questions they involve ABC. There are unknowns there, so maybe you don't know what to do, right? This one I will post to you, right? Another one, answers for the question. Okay, now you can freeze the screen there. Look at the answers. They are in blue color and the working black color. So you just how to say, you just look at the answer. Because this is a video, it is moving all the time, so you pause it to look at the working and answer. I'm not going to show you very long. I go on to the next one. Yes, the last question, right? So if you want to look at the working answer, if it's too short the time, you just pause the video. Okay, you just pause the video and you get this. Okay, so next lesson, I'm going to show you this one. Skip, this one skip. I'm going to show you how to solve some of these difficult questions. Ganga will be very interested in how to do. Ganga, Liu Ying, they will be very interested. Farish, you can try. Farish, try, then don't know, you ask me. Okay, right. So stop. Then any question? We have
No,
50
sir.
participants. No, huh?
No, sir.
No, then you go home, you try assignment 3. Assignment 2, no need to do. Assignment 3. So do 3, then which one you cannot do, I'll show you here next lesson. You post at the wall. Post
Okay.
at the wall there, you tell me what are the questions you cannot do, then I will show you. I will use that as an example to show you. Okay, then the other questions I will work out and I show you in the video also the question. Okay, so in the, as you can see all the answers. Okay, if you have no questions, thank you very much.
Thank you so much, sir.
Yeah, welcome.
Thank you, sir.
Okay,
Thank you, sir.
and you can end
Thank
the
you, sir.
meeting. Yeah, bye.